The following program was generously supported by an educational grant from General Atomics.
Welcome, everyone. It was 65 years ago, come December 2nd, that Enrico Fermi and his colleagues at the University of Chicago were able to succeed in performing the first self-sustained nuclear reaction. It was part of the Manhattan Project and an integral part of the later development of that project, and it also was a very key piece in developing atomic energy in the United States and in the world. The Manhattan Project in the United States was a key event from at least two standpoints, one of which was that it brought together a group of eminent scientists literally from around the world into one country and devoted to one theme. Secondly, it was the first time that scientists in the United States had a real voice in public policy and in development of it. So today, we're going to hear from our two colleagues that have been involved in that project and also subsequent to that in the development of policy in the United States and others associated with it. On my left is Herb York. He was in the Manhattan Project as a youngster. He worked with E.O. Lawrence, Nobel laureate, developer of the cyclotron after the war in his graduate studies. At a very early age, he became the first director of the Lawrence Livermore National Laboratory, and after that, we're proud to say, he was the first chancellor at the University of California at San Diego. He was on one of the first president's science advisory committees working for Dwight D. Eisenhower. He was an ambassador and chief negotiator for the Comprehensive Test Ban negotiations under Jimmy Carter. He's also the founder of the IGCC here at UC San Diego, and he's won numerous awards. Number one on my list on that is the Fermi Medal, which was awarded to him by President Clinton. He's won the Lawrence Medal. He's won the Leo Szilard Medal by the American Physical Society, and he's a member of the American Academy of Arts and Sciences. Murph Goldberger was president of a small technical institution in Pasadena, California for 11 years, the California Institute of Technology. He was also, after that, the director of the Institute of Advanced Studies at Princeton, New Jersey. He was the Dean of Physical Sciences here at UC San Diego, and he is also one of three founding members of the Jason Group, a science advisory group to the Defense Organization. He was on the President's Science Advisory Board for Lyndon Johnson, and he was co-chair of the National Research Council's Committee for the Study of Research Doctorate Programs in the United States. Murph has won numerous awards. He's a member of the National Academy of Sciences, the American Academy of Arts and Sciences, the American Philosophical Society, and he's the holder of 6 honorary degrees. So we'd like to start with the Manhattan Project. Like many of the most prominent physicists and scientists in the United States in the 20th century, the Manhattan Project was an important component of their lives. Herb, could you give us some description of the Manhattan Project and that experience and how it was for you and the rest of your career in a bit?
Well, it was one of these things that determines everything that comes afterwards. The war was on, we were losing the war. That is to say, the Japanese in the Pacific, the Germans in Europe were every day in the newspapers, the map showed they were getting more territory. So like everybody else, I was eager to get somehow involved in getting this war won and over with. And the opportunity for me came to join Ernest Lawrence at Berkeley. I had other opportunities, but none like that. I was really thrilled at the idea of coming to California. I was raised in Western New York, never been west of Buffalo. And the idea of coming to California with, the Golden Gate, San Francisco, the redwood trees was a great opportunity. And I knew about Lawrence as a young graduate student at Rochester. I knew about him and the cyclotron and the great things that were happening at Berkeley, so that attracted me too. So I came to Berkeley in 1943 immediately, met Lawrence and other wonderful people right away. Then went to Oak Ridge, and I was at Oak Ridge when the war actually ended.
Mm-hmm. Murph, how about yourself? How would you remember the Manhattan Project and being involved and what it did to you and how you were involved?
I was in the Army, and at a certain point, it was decided to take people who had some degree of technical training and put them into something called the Special Engineering Detachment. And we were assigned to one or another of the sites of the Manhattan Project, Chicago, Los Alamos, and Oak Ridge. I had a marginal undergraduate degree from Carnegie Tech, and the man who had been the chairman of the physics department there was the one who rescued me from the South Pacific. I wasn't there yet, and got me transferred to the Chicago Project. And I was a very junior person on that project. The job in Chicago of the division that I was associated with, which was the theoretical physics division, was to design the production nuclear reactors in Hanford, Washington, to produce plutonium ultimately used for bombs. The job was fairly well in hand by the time that I got there, though I did work on various aspects of that particular mission, and later on in a number of things having to do with advanced designs of nuclear reactors. The problem that was posed was, in a certain sense, posed to our division was a soluble one, in the sense that there had been an experiment, the famous experiment on the athletic fields in Chicago by Fermi, of a controlled nuclear chain reaction. Our problem was to scale it up by an enormous factor. Roughly, that first reactor ran at a few hundred watts. This one that we were trying to build in the state of Washington was 100 million times, produced 100 million times more power. For me, it was an opportunity there to learn how you do research. I was really terribly inexperienced, and I learned an important lesson. You have an idea, or someone orders you to do something, and you don't feel it's wrong to assume that you have to read every single paper that's ever been written on the subject. What you do is you start in the middle, you go forward, and you go backward, and you go forward when it's necessary, and that's the way you get the thing done. I met a large number of people on that project who were very well-known scientists. They were in the division I was in, they were mostly physicists. They were working on a largely engineering problem, and there were no handbooks of how you build a nuclear reactor at that time. So the physicists did much of the traditional work of engineers. Many of the people I met had great influence on me later in my life, none more so than a beautiful young woman named Mildred that was with me for 62 years. The Chicago Project, one of the early things that you learned in the Chicago Project, emphasized more the war in Europe, and particularly the feeling that the Germans, who discovered the physical phenomenon that made a chain reaction possible, might be well ahead of us. And that was a driving force on the project.
Well, when one reads the history of physics and the people involved with physics in the development of the 20th century, there's certain names that come up over and over again, one of which is Enrico Fermi, who you studied with and came to know very well. I was wondering if you could tell us a little bit about Enrico Fermi as a person and his science and how you came to interact with him.
I didn't meet Fermi while he was on the project in Chicago. He was working for the few months that we overlapped at a different site. but I did have the privilege of having him be the person I worked with on my thesis. And Fermi had a very marvelous approach to science that I've always tried to follow. One of his friends, who was sort of a mangler of the English language, said that Fermi is a physicist with a capital F. But he was a physics machine. That's all he did. And he had a marvelous gift for proceeding to figure out how to make things work. He had great mathematical power, but he didn't fuss with insisting on using fancy mathematics. He wanted simply to get the answer. His greatest gift was his ability to make a simple model of the physical process he was trying to study that he could analyze completely. In contrast to what frequently happens now, and I find discouraging, that students set up a description of a physical phenomenon with absolute rigor and in unbelievable detail, and then they go to a computer and they get out an enormous pouring out of data, but they never get a feel for what's going on.
Well, Herb, you worked for Lawrence and came to know him well. He was, of course, a Nobel laureate, the discoverer of the cyclotron, and an important member of the Manhattan Project. And you also knew Fermi. Maybe you might want to comment on your interactions and what they were like.
Well, I knew Fermi well after the war at Los Alamos, and then I knew him also as a frequent visitor to Berkeley. Berkeley was the center of the world for experimental high-energy nuclear physics. Everybody came there from time to time. Fermi came. Well, Murph was talking about Fermi as a fabulous physicist. I remember that he liked to, in a personal way, he liked to ask rhetorical questions. And I was present one day when he said, "Don't you ever wonder where everybody is?" And we knew immediately he was talking about the supposed people in the UFOs.
Right.
And Fermi went on to discuss what later became known as the Drake equation, which has to do with the probability of aliens visiting. He speculated about what he would do if he was Pope. He talked about another rhetorical question discussing the first 50 years of his life. Was the world a better place or not? And he loved to ask questions which sound as though you can't answer them, but you can if you think about it, such as how many piano tuners are there in Chicago? But I saw him, as I say, both at Oak Ridge and both at Los Alamos and Berkeley. Lawrence I met very soon after I arrived. I was tremendously impressed right away. He was a big man. Mm-hmm. He was very optimistic. He nearly always had a big smile on his face. He was very energetic. He was more of an inventor than a physicist, but he made some marvelous and interesting and important inventions. In later years, when I was working there around the cyclotron, my fondest memories are of him coming around typically in the evening. I got a lot of time on the cyclotron in the evening because the faculty members, they wanted to work in the daytime, and the evening time was left for us graduate students. And he very often, and most nights when I was there, he would come around and ask me what I was doing. And I would briefly explain, nothing particular deep, but from the point of view of a young graduate student, you know, a great inspiration. And the same thing when I was out at Livermore later, he would come out and visit the laboratory, and we would have wonderful conversations.
Well, in this world of interesting figures in science and policy and the 20th century, when one reads the history of the Manhattan Project and the subsequent history in physics in the United States, the one figure that stands out in interest and different is Robert Oppenheimer. And you, of course, had many interactions with him, and I was wondering if you could tell us your perceptions of him and what he was like as a person.
Well, my perceptions are fairly specialized because my principal relationship with him was the first year after the war, when I was a graduate student at Berkeley and he was one of the professors. So I had him as a teacher, And I remember him as an especially interesting teacher, very intense. He really knew things that other people didn't know and tried to impart some of them to me. There are many famous characteristics of his, which I also remember from those days. One is a pork pie hat, which he would come to class wearing, sometimes even during the class. He would smoke, again, when he came in, and usually also during the class. And then he had a very special cough. And most of his students, other graduate students, those who worked really with him intimately, for whom he was their research advisor, most of them adopted this same cough. You could tell who was an Oppenheimer student and who wasn't. I have to say I knew his brother better, and his brother was just 10 years younger. People here may remember that he was in self-imposed exile for about 20 years, and then when he came back from exile, he founded the Exploratorium up in San Francisco. Right. And Frank was my immediate supervisor at Berkeley.
How was Oppenheimer as a lecturer in the physics class?
Well, he lectured to the best students. He gave the rest of us a little trouble, but I do believe that I've had, he was sort of middle as far as I was concerned. I had lecturers who were much more difficult to follow than him. He liked to present things with enormous steps. The first line on the blackboard would be 1 minus 1 equals 0. Then the next line would be some complication about alpha decay. And then he would turn, perhaps with his cigarette, and he would say, "I hope I'm not being too pedestrian." So he was a very memorable professor, I have to add. Then I heard him lecture on the political scene too, which is where we're getting later. Yeah. He would, after he had left Berkeley and was focused mainly in Washington and New York, he still came on a number of visits, and I remember some extremely important meetings, big public meetings at which he expressed his views about the arms race.
Mm-hmm. Thank you. Murph, you've also interacted with Oppenheimer on many occasions and knew him in a different capacity. Could you tell us a little bit about that?
Oppenheimer was, I think, 39 years old at the time that he led the project in Los Alamos. Many of the people that we have and will talk about were similarly extraordinarily young. I've often felt if there were a national crisis, I wouldn't want the safety of the nation to be in the hands of such whippersnappers. But Oppenheimer was an unusual choice to be the director of Los Alamos, but he, according to everything I've been told, he did a superb job there. I met him first in 1948, actually, as he came through Berkeley. He was extraordinarily quick at understanding things that people said. He was the person you turned to summarize a conference and all the things that were described. He wasn't doing any physics anymore himself in 1948. He'd been totally distracted by his association with issues having to do with politics rather more than in science, but he was so quick that he could do that particular job. He was a great teacher in the sense that I know of at least 3 textbooks based on three different sets of lectures that Oppenheimer gave. He had very good taste in understanding what it was that was important. He tended to be a little pretentious as far as his intellectual pursuits were concerned. I know my wife didn't get along with him very well for that reason. But then, of course, the defining moment really in his life had to do with what I usually refer to as his crucifixion in 1954, and that particular episode of his life.
If I remember, there was some instance that you relayed to me once or twice over lunch. It had to do with maybe New Year's Eve and Robert Oppenheimer?
Yes. My wife had organized a New Year's Eve party in the firehouse in Princeton, local firehouse. They had a big recreation room. And we all had it all decorated, and all of our friends were there, and everybody was having absolutely great time. And very close to midnight, who comes rolling in but Robert and Kitty Oppenheimer and Niels and is it Margareta Bohr. Well, everyone was, of course, immediately drawn to them to interact with these great people. The party went downhill rapidly after that, but there was no restraining the crowd. One thing Herb mentioned that I think is very important to make sure that we don't forget about. We came out of our PhDs at a time that was really a golden age for physics. It was at the time when elementary particle physics was born. Exciting things were going on all the time. And it was an absolutely great opportunity for young physicists, both in experimental physics and in theoretical physics. The funding agencies that were around at that time, to the extent that they were there, the Atomic Energy Commission had responsibility for anything that had the word nuclear in it. And the armed services wanted to support research. And I remember once Fermi went to Washington to try to raise money to build an accelerator at Chicago. And he came back sort of shaking his head. He said, you know, they just throw the money at you. So it was really a wonderful time to be in the midst of
well, one thing, he reminds me, at nowadays on the largest accelerators in the world, at Geneva and in near Chicago, it's typical that the papers are signed by 100 people.
or 500.
And from 10 different institutions who work in some complicated, coordinated way. At Berkeley, I was working as an experimentalist with the largest accelerator in the world, the ancestor of all of these, and I had it to myself 10 and more hours a week, you know, and wrote papers with just one or two other authors. It was an entirely different and enormously exciting time, and I must say I would never have foreseen the current situation with these enormous teams, you know, organized like a little industry making these measurements. There's just been a number of articles on the Big Hadron detector at Geneva, which reminds me and others about how different it was, different it is today.
You had mentioned, Murph, in your previous statement talking about Robert Oppenheimer and the crucifixion. It's a well-known instance, and we've all read about the 1954 hearings of Robert Oppenheimer when he had his security clearance revoked, and we've read testimonies about it. But what was it like, and what was your perception as being a physicist in the community and being surrounded by the people and involved with the people that had to testify, the tellers and whomever else that was involved? How was it taken by the community? What was the discussion like?
The community, in a certain sense, was split, though I think the bulk of the sentiment was on Oppenheimer's side and felt that he had been poorly treated by Teller. The tension between Teller and Oppenheimer went back to the days during the war at Los Alamos. Teller, even then, was completely almost obsessed with the idea of making what ultimately turned out to be the hydrogen bomb. He also resented the fact that he was not made the head of the theoretical physics section in Los Alamos. And what happened was that he and a small number of people went off by themselves. They did not work on the atom bomb that was being designed at Los Alamos, but they did their own little thing. So the tension was really had a history to it. If you ask me what side I was on Oppenheimer's side.
Mm-hmm. But what was it in your colleagues in physics today? There must have been a lot of discussion about the trial and the proceedings.
Well, there was, and well, Oppenheimer made a number of mistakes, I believe, in the way that hearing, it wasn't supposed to be a trial, was conducted. his lawyers were not allowed to see classified material. The prosecution lawyers were allowed to. He chose a lawyer who was not experienced in the kind of situation that he was supposed to, that he had to deal with. And Oppenheimer was a very difficult. He didn't help his own cause in the course of the testimony. He was a very complicated man. And as I say, I was on his side.
Yeah. How about yourself?
Well, I was uncomfortably close, because the two people that I was closest to at that time and who were involved in this were Ernest Lawrence and Edward Teller. And they were the leaders of the small group of scientists who wanted Oppenheimer out of any position of power. And so I was director of Livermore at the time. Ernest Lawrence would come out and visit. Teller spent several days a week there. And so I was in touch with them all during the period when this was building up. So I saw it coming, and I saw they were very nervous about it. They knew it was going to cause trouble. Teller did go and testify against him, was the key witness. Lawrence was on his way to testify. He became ill. He stopped at Oak Ridge, where he talked with a couple of his good friends, whom he thought would be obviously on his side and whom he discovered were not, Al Weinberg and Clarence Larson. And he was stunned. Lawrence was stunned. He suffered from colitis, a serious disease that's exacerbated by nervous tension. And instead of going to Washington to testify, he came home. And I remember talking with him about it after he did. Others from Berkeley also testified against him. Alvarez took a kind of an intermediate position. There were other faculty who took an anti-Oppenheimer position. I regarded it as a tragedy even at that time. I didn't get directly involved. I was completely absorbed in just getting Livermore going at that time. Laboratory was only 2 years old. And I was determined that that kind of extra outside tension was not going to disrupt, getting things going. But I didn't like it, and although I didn't argue about it, I have to say, with either Teller or Lawrence, I also felt that it was wrong to do. That, given the service he had done for the country at Los Alamos and elsewhere, it really was, as has come to be called, a tragedy. But I didn't argue about it and didn't play any role in it. But as I say, I was uncomfortably close. And in a way, I had another. I also was part of the reaction, because, as Murph says, nearly everybody, not quite, but nearly everybody actually supported Oppenheimer in this. And one result of that was that Teller, who was then spending several days a week at Livermore, was known as everyone knew that he was the primary mover. And so there were many people who simply wouldn't come and visit. Now, there were others who did. Von Neumann came, Wheeler came, and some of the other greats. But others like Fermi and Rabi and so on would decline to visit Livermore, because Teller was there, and not only had he taken this action with respect to Oppenheimer, but in creating in promoting Livermore in the first place, he had regularly bad-mouthed Los Alamos. Yeah. Which even preceded the hearings, and so that the bad relations between Teller and the rest of the world started a couple of years before the Oppenheimer hearings, and of course were greatly exacerbated by them. And he knew that it would be great trouble. As time went on, in later years, I occasionally heard him talk about it. 10 years later, 20 years later, even 30 years later, Teller lived on well into his 90s. He became more bitter about it, and instead of softening his views about Oppenheimer and moderating his position, it became more strident, both in private and in public. That is, Teller's view of Oppenheimer became more negative, and he was more strident in expressing it. So it was a tremendous tragedy, primarily for Robert Oppenheimer, but it was a tragedy for both Lawrence and even more Teller as well.
I was reading an accounting not so long ago of the development of the cyclotron by Lawrence, and the development, it's striking because it was so much different in those days, as Murph was saying a little bit earlier, that there were no funding agencies. And the money that he raised for the magnets for the cyclotron was done privately from people in the Bay Area. Well, after the war, it was the infancy of a lot of what are now funding agencies, the National Science Foundation, the Office of Naval Research, the Atomic Energy Commission. What was it like in the development? What are the challenges with getting those going, and how did it work, and what was your perception of how that happened?
Well, in my particular case, I had no problem getting money. The first 4 years after the war, the first 6 years after the war, I was at Berkeley, and we were the biggest center in the world for that sort of thing, and it was Lawrence who got the money, and I was benefiting from it, and I didn't see it as a problem at all. Then when I went out to Livermore, it was the same thing. They were eager to put money at Livermore. I mean, I remember Alvarez during the formation of Livermore. He was back in Washington. He said they wanted me to bring it home in a wheelbarrow, you know, the money, so that we never had a problem. You know, it always seemed as though there was not enough money. I mean, any large scientific research institution can always invent more things to do than it's got funds to support. But basically, in my experience at both Berkeley and Livermore, money was easy to get. Now, I never had the experience of the individual scientist who has to write a proposal and go back and get the money on his own. For me, happily or maybe not happily, I didn't experience that.
Murph, what about yourself and the development of the AEC and the NSF and funding agencies and the change in the culture of the United States in funding scientific research?
I didn't have much call to be involved in that, Mark, for the most part. I was always at wealthy institutions that always seemed to have plenty of money. I'm the University of Chicago and Princeton, and they were just rolling in money. And I was not in a position to feel any particular squeeze. You know, theoretical physics is a very cheap thing to fund. I did have a contract with the Air Force Office of Science and something or other, and I had a very rigorous contract to fulfill. It was called Problems in Theoretical Physics. And I didn't even have to write a report at the end of the year. So I didn't face the real stringent.
One a prominent physicist who also wrote songs wrote one. It starts out saying, "Take away your $1 billion, take away your tainted gold. My heart is pure and will not be sold." You know, that was a man named Roberts.
But was there discussion within the community, or especially in the development of the National Science Foundation? And I've heard you discuss later on both of your development or insertion in the process of the development of NASA. And how did those discussions go, and what sort of involvement was there in the community?
I was part of the White House committee that planned both the organization of NASA and the first program. Mm-hmm. And of course, it was a very exciting thing to do. There, the situation was that the public was very dissatisfied with what had happened. The Russians had put up the first artificial satellite, Sputnik. The public felt that there was something seriously wrong with American science, with the American support of science. And Eisenhower, one of his reactions was to establish a scientific advisory committee. I became part of that. And one of the first things we did was to plan NASA and ARPA, which also was deep in the space program at the beginning. And we planned both the organization and the program. And but there again, it was in response to a public demand that something be done. And again, it wasn't hard to get money. Yeah. For either of those organizations. and it wasn't hard to gin up ideas, especially with regard to space in 1957, 1958. You know, everybody with a garage with some tools in it thought he could potentially contribute to this if we just give him. He was having a hard time getting money, but the person with the garage and the tools. But the ideas were just coming from everywhere. I mean, I think of it as they're coming out of the woodwork. You know, there were people storming Washington with proposals about how to solve this terrible problem, which Sputnik, as the first artificial satellite, represented. And then, of course, we also took up questions about how to improve higher education, especially in science. And there already was a system for providing grants in Science Foundation, Atomic Energy Commission, and so on. But all of that was greatly expanded in response to Sputnik.
Sputnik, of course, in the eyes of some, posed a real national security issue. That is, that the Russians had, it was felt, had large numbers, or had the capability, certainly, of building large numbers of rockets that could be used to drop bombs, nuclear bombs, on the United States. And there was a great deal of concern about that, especially when our first efforts with launching spacecraft were so miserable, and failed so miserably.
Well, Herb, you're certainly right that Sputnik was one of those events that did do a lot to shape education. I think anyone who was going through elementary and high school or junior high school at the time remembers hearing about Sputnik or hearing the recording of the emissions from Sputnik, and it really made a huge impression on everyone. Herb, you were the first director of Lawrence Livermore and also our first chancellor here at UC at San Diego, but it really was a remarkably young age, as you say, as Murph said, a whippersnapper sort of age. I wonder if you might comment on that a little bit. Was the experiences that you gained during the Manhattan Project or graduate school or Lawrence, how this came to pass, and if those experiences had any bearing on your later becoming?
Well, it was Lawrence. Without him, these things wouldn't have happened. And it was really Lawrence who appointed me as director of Livermore. His influence in Washington and with the Board of Regents was such that he could do that. You know, it was an unusual thing, but he was able to do it. And he had confidence in young people, not just me, but young people generally. Mm-hmm. And he frequently remarked on that. But I observed the way he ran the Berkeley laboratory. I decided that was great, just right to promote, you know, science, good science, get things done, fight, you know, with a minimum of bureaucracy. And so I wittingly organized Livermore and ran Livermore the way I thought he would want it done. I didn't ask him about it. We didn't really talk about it overtly, but I organized and ran Livermore the way I thought Lawrence would do it if it was him instead of me.
That's really a remarkable change in the procedure of doing such things, that a director being mandated almost by a single person as compared to now, where the process takes
a big committee.
When do you think that change in the culture of doing things happened?
It happened steadily. And it accelerated when the wartime group, you know, began to pass from the scene. Mm-hmm. When Lawrence was running Berkeley and then also Livermore with me as his agent out there, and Bradbury was still running Los Alamos, and Oak Ridge was still in the hands of people who had been there in the war and so on, they were able to get along with a minimum of bureaucratic regulation. Mm-hmm. But when they passed from the scene, the next group that came in, you know, the regulators got there first, and it made a big difference. Of all the atomic energy laboratories, now the Department of Energy laboratories, the only one that was founded by its director was Lawrence Laboratory. Mm-hmm. In all the other cases, somebody decided to have a laboratory, and then they went and got a director. Lawrence was the only one who came first. I mean, there was Lawrence, he got these ideas and built a laboratory to accomplish them. But the bureaucratization of the management of science and the regulations, the rules, grew steadily. I mean, there wasn't a crisis that brought it all about. There were a series of them. People will remember some of the recent ones. There were some security problems at Los Alamos and some lost information. There were a lot of other instances in which somebody thought the money was spent improperly. And every time something like that happened, we got a new regulation, and if it was bad enough, we got a new layer of bureaucracy. So it was a steady thing, and of course it wasn't just in the management of science or the management of education, it was everywhere. Mm-hmm. When we started Livermore, I was able to just sit by myself and decide what the salaries of the next half a dozen people should be. Then the next time Lawrence came out, I would tell him, these are my ideas about what Harold Brown, Johnny Foster, and so on should get. And then he would usually raise one of them, then he would set mine, and that was it. Neither the regents nor anybody in Washington really made any further changes. We just did it like that. And that's the way we appointed division directors, deputy lab directors, and so on. Entirely different. Yeah. We had it especially good at Berkeley and Livermore, but the whole world was something like that. And that just slowly changed to where none of those things, all of those things are done by large committees operating under a very fixed and extensive series of rules. It's no better. The result is no better. It just simply takes much longer to achieve it. Well, a few smart people operating on knowledge plus intuition do just as well as a committee does, maybe better. The committee does present an image of being fairer. They cast the net wider, they consider more possibilities, but they don't produce a better result. And I think that's true in the laboratories, I think it's true in education, it's true in the government generally.
Well, Murph, in your case also, you became president of Caltech at a very young age, and later the director of the Institute of Advanced Studies. And even after that, you were one of the three founders of the Jason Group. Could you tell us a little bit about how your background with the Manhattan Project may or may not have played into that, and how this came to pass at such an early age that you got involved with such things?
Well, what happened to me was, to a lesser extent, I think, than her, my experience on the Manhattan Project. I'll come back to that, though. What they say about university presidents is they have to be smart enough to do the job and dumb enough to think it's important. I drifted by first becoming a department chairman. That was my first taste of academic administration. And I got that job because I complained to one of my colleagues that the two people who really wanted it would be disasters. He then went to the president of the university, who showed up in my office the next day and offered me the job. And that was the beginning of, in a certain sense, my downfall. It had becoming even as little as a department chairman certainly had an impact on my scientific research. I did have a role in starting Jason.
Right.
And that's a rather interesting subject for this particular institution. Let me tell you what Jason is. Jason is an organization of scientists. Originally they were largely physicists, but now it has a much broader representation that works to advise the government on things having to do with national security, and they also work on things which are not classified. It came into being in 1959, in part because of the times. It was a Cold War time. Some of us had been asked to serve on various committees of one sort or another, and all we saw on those committees were these old war horses from World War II, from the Manhattan Project, and thought that it was time for a new generation to step up and take some responsibility. The international situation had a great deal to do with our deciding to make the commitment that we ultimately did. Three of us who essentially started Jason all live in La Jolla. It was alleged that one of the other founders, Kenneth Watson, was going to be here, and another person who is certainly known to this community is Keith Bruckner. But we felt that it was time for us to try to get involved, just because of the nature of the times. It has been meeting in La Jolla for many, many years. We used to go back and forth from one coast to another, but it's been meeting in La Jolla now. I don't even know exactly how many years. And as I said, it has broader representation, and not just physicists, and no problem in recruiting young people to come and work. I don't know exactly what it is that turns them on. There's a certain, of course, there's a certain attraction to knowing secrets that not everybody else knows about. But I don't know any of those young people well enough to find out what it was that really got them involved. I've occasionally thought in retrospect I might have been better off personally if I had not gotten so involved in these extracurricular activities, that I did damage to my scientific career. But at any rate, I did. I can't undo it. And
the name?
The name Jason, well, when we first formed the group, and Herb, I have to come back to the fact that Herb played an important role in this also. The Pentagon has a machine that spits out names for projects. And they came up with the name Project Sunrise. And I came back and told that to my wife. And she said, "That really stinks. You should call yourself Jason." Now, the reason she said this is that there was a branch of an organization known as the Institute for Defense Analyses, located in Princeton, that we had some peripheral association with. And they had a colophon that looked like a Greek temple. And so she thought Jason was a good name, and there was also the Argonaut business in the background. We were going to get rich on this. We were paid initially $50 a day. I was the chairman, so I got $75 a day. You can't hire very many people as consultants at those rates, I have to tell you. But it was an interesting experience, and the group has survived and continues to thrive.
So, Murph, as president of Caltech, you had a few people on the faculty that are rather well known as being interesting characters. Are there any one or two that might stand out in your minds? You know, was Richard Feynman an easy person to get along with, or Murray Gell-Mann, or some of the well-known people in physics?
Well, Murray Gell-Mann and I went back a tremendous time. I spent a year as a postdoc at MIT, and when I arrived there, this small child came up to me and he said, "I've read all your papers." Now, it wasn't such a heroic job at that time. There weren't all that many, that many of them. But I found out that he had indeed read all these papers, and that he was obviously extremely smart. But his thesis advisor, who was a man named, Herb mentioned, his name was Victor Weisskopf, somehow didn't think he was very smart. And I had all this vast experience of working on the Manhattan Project and having worked with Enrico Fermi. Right. He and I became very close friends. And when I got a job at the University of Chicago in 1952, I think it was, no, 1950. First thing I did when I got there is I told Fermi, we have to hire this guy. And he asked me, what has he done? And I said, never mind what he's done. He's at the Institute for Advanced Studies, and we just really have to get him. He had no publications to his record. And I persevered, and he came, and he and I were friends and collaborators for well over 25 years. We were very close to his first wife, when his first wife was alive. She died tragically young of cancer. Feynman was, of course, an interesting person to be around. When I arrived there, he was in the hospital, having just had a massive tumor removed. And I went over to see him. I knew him quite well from conferences and the like. And he said, I'd rather be where I am than where you are. and the other thing he said, I won't do anything you ask me to do. Well, he got better about the last one. And he was an incredible intellect to be around.
May I comment on Jason?
On Jason, sure.
I mentioned earlier being in the White House and the time after Sputnik, all these ideas were coming in, just a flood of ideas. At the time Murph talking about the founding of Jason, I had moved over to the Pentagon, where I was in the same position. I was the principal scientist and engineer over there. And we were also flooded with ideas. And the idea of forming Jason was one of those ideas. And I knew Ken, and I knew Ken and Keith and Murph. We had all been at Berkeley 10 years before that, and so we knew each other. And when these guys came in with this idea about a very special summer study think tank combination, I thought it was a good idea. So I found the money that actually got them. It was money that I organized that got them started. And I think, just to boast a little bit, that if somebody else had been in my job in the Pentagon, they would not have funded Jason. I think I was just the right person at the right time to do that. And I have to say that in return, Jason has treated me very well ever since. I do attend their meetings and listen to what they have to say up to this day.
We're both what are now called senior advisors.
I see. As we started the program, we were talking about how the Manhattan Project brought together this group of scientists in a really unprecedented sort of way. And then we tiptoed around a little bit about after the war, the Cold War and Sputnik and the arms race and the insertion of scientists and Jason also into the process of developing that. How do you see things today in the scientists and their involvement in the community and making decisions? And do you see that we're doing what we should or what we might not be doing? I mean, for example, the issues with climate change or stem cell research. Are we being involved as a scientific community as we should be? Or the younger physicists and chemists and mathematicians or engineers being involved as they should, as it was in those days? Or should we be doing something differently?
Well, I personally am disappointed with the role of scientists in supporting decision making and advising high-level decision makers. But it's not just advisors; they're the ones who participate as officials as well. Mm-hmm. But in both of those categories of people, now is not a good time. The peak of that was quite long ago. It's not just the last few years that things have backed off. But way back in the 60s, the President's Science Advisory Committee gradually lost its status and importance for a whole variety of reasons, one of which was that the bureaucracy acquired better capabilities of its own. At the time that we started the President's Science Advisory, that Eisenhower started the President's Science Advisory Committee, the bureaucracy was really very weak. Mm-hmm. And so they really needed advice, and they couldn't get it internally. Now there are people internally who can provide the same kind of advice, but the status of science at the present time just isn't what it was, and we're poorly off because of that. But the problem, there's not much science can do about that. The Academy can organize studies. The American Physical Society can organize studies. Those organizations are so big and so important that they can sort of force their way in. But lesser things, I mean, the old advisory committees, if the people at the top don't want to listen to them, there's not much you can do.
Yeah.
I mean, you can't really force your way in the door and be very effective. Some people are able to get the backing that will force the way in the door. They can get a congressman's ear, but he's not listening. Unless he invited you in, he's not listening. And so right now is an especially bad time, but it's been drifting in this direction. It's not just this administration. It's been drifting this way for quite some time. And I must say, I don't know what to do about it. I do think that we're losing something. We've lost something.
I want to comment on this. I feel very strongly about the urgency and necessity for a number of things to be done that, in some sense, have to be led by the scientific community. There are at least three sort of overwhelming problems that the country faces at this time. One has to do with climate change. A second has to do with energy resources. And a third has to do with the possibility of proliferation of nuclear weapons. The climate change issue is unmistakably upon us, and I've become tremendously concerned about that because I'm convinced by the things that have recently come to light that it's not just that our grandchildren might be threatened by the implications of climate change, but our very own children, and my children are in their 50s, might be seriously impacted by the consequences of our not doing something much more in connection with climate change. And that is something which threatens the planet. And we have to try to engage both politically and affect efforts on the part of the scientists to deal with this. There's a man named John Holdren who either was or is about to step down as the president of the American Association for the Advancement of Science. And he put the matter very well. He said, there are three things that we have to deal with: mitigation, accommodation, and suffering. And we're going to do all of those in connection with these climate change issues. The only question is the mix. The more mitigation we do, the less accommodating we'll have to do, and the less suffering we're going to do.
Yeah, that was a very interesting comment you made, Murph, about the climate change and the necessity, and it really is an issue that transcends any single discipline, and it is global. Thanks, Herb, and thank you, Murph, for a lot of very interesting comments, and thanks to the audience for coming here today.
This program was made possible by an educational grant from General Atomics.